Hi everyone. In this video, I'm going to go over the definition of the derivative and show you how we find the derivative function using this derivative. The derivative function is a function that gives us the instantaneous rate of change or the slope of the tangent line of the function from which it was derived or differentiated. So the definition of the derivative, f prime of x, using the limit definition, is the limit as h goes to 0 of f of x plus h minus f of x all over h. You may remember that this is the difference quotient. And again, this is the slope of a secant line. We would have the y2, the value of y at x plus h, the y1, the value of y at x. And then we would have x plus h minus x. The x is canceling out to give us h. So y2 minus y1 over x2 minus x1. And then we just take the limit as h goes to 0. This gives us the derivative. Now there's different notation that we use, courtesy of the people that were originally part of the development of calculus, Lagrange and Leibniz. Here we have f prime of x. We would use this notation. We would call it f prime of x. We might also see y prime or y prime of x maybe. Leibniz uses slightly different notation, but it means the same thing. The derivative of y with respect to x, we would use dy over dx. So we'll probably use all three of those interchangeably. They mean the same thing. So let's go ahead and apply this definition to a couple of functions and see how it works. So we have this function f of x equals 2x squared minus 7x plus 1. This is a parabola. So what I'll do first is I'll define f of x plus h, which I will then substitute into the limit definition that I laid out above. So this is going to be, everywhere we see an x here, we're going to replace it with x plus h. So I'll have 2 times x plus h squared minus 7 times x plus h plus 1. And now I'll go ahead and simplify that out. This will give me 2x squared plus 4xh, I'm distributing the 2, plus 2h squared minus 7x minus 7h, I distribute the negative 7, plus 1. Okay, so now I'll go ahead and put this into the limit definition of the derivative. This would be my f prime of x. This limit as h goes to 0 of f of x plus h, so that's 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 1 minus f of x, which is the original function up here, 2x squared minus 7x plus 1. I'm going to put parentheses around that because the negative sign will get distributed. All of this over h. Now again, for this limit here, I'd like to substitute in the h equals 0, but I can't do that because it gives me a 0 in the denominator. So what I'll try to do is simplify this all out, the numerator here, and see if I can factor out an h that will then cancel with this h in the denominator, allowing me to do a direct substitution. Now what you can see here is if I combine like terms, you'll see I have this 2x squared here, which will cancel the minus 2x squared, cancel that. I also have a negative 7x here, which with the negative here and the negative here gives me a plus 7x, so that'll cancel negative 7x plus 7x. And then I have a plus 1 here minus a plus 1 there, so those all cancel out. So I've canceled all three terms in my original f of x. And now let's see what we have left here. I have a 4xh plus 2h squared minus 7h. Notice that all three of these terms have an h in them, so I can factor out the h, leaving me with 4x plus 2h minus 7 all over h. The h's cancel, and then if I take the limit as h goes to 0, now I can do a direct substitution of h equals 0 because I don't have that 0 in the denominator. In fact, that makes that term go away, leaving me with a 4x minus 7. That is my derivative function for this function up here. And this gives me, again, at any value of x, this will give me the instantaneous rate of change or the slope of the tangent line to this curve at that point. Okay, now applying it here, at a slightly different notation, I have y equals 1 over x, but that's synonymous with f of x. So I can use this same definition. I'll first define my f of x plus h, which is going to be 1 over x plus h. And then I will put this together in my limit definition. Again, this is my f prime of x. This is the limit as h goes to 0 of f of x plus h, which is 1 over x plus h, minus f of x, which is 1 over x, all over h. Okay, so now this one's a little bit trickier in that I have to find a common denominator and combine these terms here in the numerator. So the common denominator is going to be x times x plus h. So what I'm actually going to do here is I'm going to multiply both the top and the bottom by x times x plus h. X times x plus h. Now, so again, I can't do a direct substitution. I get a 0 in the denominator if I set h equal to 0, so I can't do that yet. But I'm going to try to factor out an h and cancel it again like I did over here. Again, this one is a little bit trickier because we have the fractions. But I'm going to take the limit as h goes to 0. Now multiplying this x times x plus h times both of these terms, when I multiply it by this term, the x plus h cancels, leaving me an x. And when I multiply it by this term, the x's cancel, leaving me with the x plus h. There's a negative sign here, so I want to make sure I keep the parentheses there because that negative sign will distribute. Okay, that's it. In the numerator, the denominator, I'm just going to leave as is. That's h times x plus h. Just multiply straight across. Okay, now take the limit as h goes to 0. X minus x. Those cancel out. The negative sign distributes here, and I get a negative h over the denominator. H times x plus h. Notice now the h cancels. This will leave me with a 1 here. Cancels with that. And then I can go ahead and set the h equal to 0 in here and do a direct substitution because I won't have the 0 in the denominator. What I'll get is I'll get negative 1 over x times x, which is negative 1 over x squared. And that, in fact, is the derivative of 1 over x. Again, this derivative for any value of x, this will give me the slope of the tangent line or the instantaneous rate of change of this function at that point. And that's it.